law of sines, just like the law of cosines, is something that we use to find side lengths and angle measures of oblique triangles. That means non-right triangles like the one that you see here. What it does is it takes the ratio of the sine of an angle over the side length opposite that angle. These ratios can work for any pair that you have. To prove the law of sines, the first thing that we need to do is identify a formula for the area of the triangle. Now we all know that formula from geometry. That area is equal to 1/2 the base times the height. Well, for our purposes, instead of using A, because A is an angle that we're given, we'll use K to represent area. So in this case, K is equal to 1/2 the base times the height. Since the height isn't an actual side length of our triangle, we need to figure out a way to represent height using our side lengths and our angle measures. Well, one thing that you should notice is that we've got angle A here on this right triangle. So I could take the sine of A and let that be equal to h divided by the hypotenuse. Oops. So that's sine of A is equal to h divided by c. If I want to just solve for h, I would multiply by c on both sides. And I could determine that c times the sine of A is equal to h. I can now replace h in my formula with this. So now I have that k is equal to 1/2 b times c sine of angle A. I can do the same thing using angle C, that the sine of C is equal to h over A, so that A times the sine of C is equal to h. So I could write that K is equal to 1/2 B A times the sine of C. In order to use angle B, I would actually have to rotate the triangle so that A is the base and that H went in this direction. And what I would find out is that the sine of B is h over c, which means that c sine of B is h, and when I rewrote my area, I would get K as 1/2 A C sine of B. So you see here that we have three expressions that all equal K. We can actually set all three of these expressions equal to each other. So we have 1/2 BC sine of A is equal to 1/2 AC sine of B, which is equal to 1/2, I'll rewrite this as AB sine of C. Well, remember that with equations, anything you do to one side of an equal sign, you have to do to the other. So what I'll do is I'm going to divide each one of these by 1/2 ABC. What happens? The halves all cancel. B and C cancel on the first one. A and C cancel on the second one. A and B cancel on the third one. And we're left with sine of A over A is equal to the sine of B over B, and that's equal to the sine of C over C. The reciprocal of the law of sines is also true. A over the sine of A is equal to B over the sine of B, and that's equal to C over the sine of C. The reason that you might choose one form over the other is so that you don't have variables in the denominator. Let's try an example. Here we have triangle PQR, and we're told that angle Q is 52 degrees. side P is 3, and side Q is 4. We don't really know what this triangle looks like, only the fact that we have to assume that it's not a right triangle. So when I draw these, I tend to just draw a triangle. Remember that the side has the same name as the angle that's opposite. Angle Q is 52. Side P is 3. Side Q is 4. We are looking for angle P. So what I will do is use the law of sines, and I will say the sine of angle Q over side Q has to equal the sine of angle P over side P. So that's the sine of 52 over 4 has to equal the sine of P over 3. So now all we're doing is the algebra solving for sine of P, and you can do this by cross multiplying. 3 times the sine of 52 divided by 4. This gives me 0.591. Let's try that again. 5910 is equal to the sine of P. So in order to find angle P, remember we have to take the inverse sine of the function. So we'll take inverse sine of 0.5910, and that's going to equal angle P. We calculate that angle P is equal to 36.229 degrees. Next example is a word problem, and remember with word problems you absolutely must draw the picture. It doesn't have to be a beautiful picture, but you have to recognize that we are working with oblique triangles, so it shouldn't look like a right triangle. So here we've got a captain of a ship looking at a reef located so that the angle between the line of sight to the reef and the ship's course is 20 degrees. So first thing I'm going to draw is the ship's course. That's the line, this ship's course. The line of sight is this way at 20 degrees. Now the ship is actually going to move 8 kilometers, and when it does, the line of sight is now going to become 70 degrees. So the first thing that we need to do is calculate the supplement in order to find the inside angle of that triangle. The supplement of this is 110 degrees. The question asks, how far is the ship, which is now located here, from this reef? So we're looking at the side that I've shaded in blue. For this particular problem, we also need to label that third angle as 50 degrees, because remember 20 plus 110 is 130. The supplement of that is 50. We need this because in order to take the sine of the angle over its side, remember this 8 kilometers is what I've outlined in pink. So we take the sine of 50 over 8, and that will equal the sine of 20 over this blue side that's opposite the 20. And we'll call that D. This is one of those instances where you might want to put the variables in the numerator. It really doesn't make much difference. Cross multiplying 8 times the sine of 20 divided by the sine of 50 will give you the measure of D. You calculate D to be 3.572. Because this is a word problem, we have to write our answer as a sentence. The ship is 3.572 kilometers from the reef.